I will try to make you a brief tutorial of another plugin of QGIS that is very nice to be used to visualize very quickly on the fly a 3D view of a project if you have a good enough DTM and some nice images as we have in this case. So we share my screen and we will see what to do. Okay, do you see my screen? I hope so.
Yes, yes.
Okay, so this is our beautiful project. And we have here the G0 delta, the path of the Perseverance rover. And you see that we have explored the project very, very deeply in the past session. We have quite a few DTMs. We have the CTX DTM, which is the one that is basically creating the background here. And then we have also the high-rise DTM for the high-resolution part of the delta itself, of the zero. So I have to say that the QGIS indeed allows you natively to visualize 3D data. And if you go to view here, you see that you have 3D map views. If you click on this button, you will have a floating window appearing. So, but yes, my computer is stuck. Okay, because I have too many monitors attached, probably. You have a 3D view appearing of sort of a visualizer. Maybe we have to switch off a few layers because it's a bit demanding. So let's switch off everything, but let's say the CTX for a moment, okay? So let's try again. View, 3D map views, and yeah, for some reason it creates. Yeah, you know, when you do your first 3D view, you get a list of 3D views. You can create as many as you want. You can populate your screen with 5, 6, 10 3D views. You can put them also in your map layout. This was the one I created before. I want to create a new one just with this data set because the 3D view embedded in QGIS is sucking in everything that you see in your map canvas at that specific moment. And that is maintained in the 3D view. If I create a new one, and it's opening up also always on my other screen, it will create a new window. Yes, hopefully I can show it now. I mean, you already see that this is not quite friendly, let's say. Let me see if it's working. Not really, but we have super heavy data. So there are quite a few controls here. You have the compass bearing that you can basically use to rotate your object. Yeah. Maybe I can switch off some layers. Then you have other buttons like this and this that you use to basically tilt your perspective. This is the tilt down and tilt up. So tilting down, basically you incline the point of view. You can click it as many times as you want. And you will find that at a certain point, everything that you see inside this window is actually a flat plane. It is a flat plane because QGIS wants you to tell him which is the topography that he has to use to create the surface 3D. So you have to go with this button here, and you have to go to configure. You see this sort of tweezer thing button. You go to configure, and it's asking you basically, how do you have to render the terrain? As a flat terrain, or you want me to use a DEM, a raster layer? In this case, we have a couple of them. It says an elevation must be selected, of course. we have to select it. So the type is a DM, a raster layer. In this case, we can choose, for example, this. So in the elevation data, we have to go and check the N20 G0 character CTX DTN. Then you can adjust the shading, etc. But I have to say these things, my computer personally are a bit broken, so sometimes they do not work and the QGIS crashes. You can adjust the lighting direction, as I shown the previous days. When you create the shaded relief model, they shade creating light direction. This can be set, in this case, in real time. But again, on my computer, it's some issues. You can try, maybe on your computer works. On mine, it has quite some problems. So I will stick to the terrain for the moment. And simply click OK. This is the resolution. So the terrain is created this way. Of course, you cannot take a whole DTM and pretend that everything is thrown into a 3D environment and it works like charm. So what QGIS does is basically subdividing the terrain automatically in different tiles. And is rendering separately all the tiles. You can choose the tiles resolution. I will keep to this for the moment, but then we can see what's happening if we increase this value. So we can click apply and then OK. And hopefully, yes, you see there has been quite a subtle change. And it should be able now to render. Maybe it's actually rendering my 3D. It's not super snappy. Yeah? You can also take this window and you can pin it into your interface so that you can have like a 2D view and a 3D view all together. You have other options, like, for example, you can export to 3D scene. You can choose a folder. If you click here, for example, you can choose a folder. I would put it in my desktop, like Winter School State of the Art, and then it saves you a folder with inside basically the objects like an OBJ and material and texture. So it's quite convenient. In this case, on my computer has quite some problems. This is why I will also show another system. There are other options, for example, to export this as an image, to create animations, to take measurements along the polyline, straight onto the topography. So I suggest you to play with it if your computer is able to process it. Mine has a bit of issues, but give it a try. Then you can close it, and it stays here. If you go to View, 3D Map Views, now you see that I have two of them. The first one was the very first one with everything inside the project. The second one is the one I just shown you. If I create a new one, we can create as many as we want with different purposes. But then we can also use something which is a bit easier to use, which is a plugin. And it's called QGIS to 3JS. So to install it, you have to go to plugins, manage and install plugins as usual. And the name is quite complicated, is QGIS to 3JS. This one. So it's basically using this WebGL technology and 3JS JavaScript library, which is a common library for embedding, for example, 3D objects into browsers. And it's able to visualize on the fly and then export also the 3D model in different formats, for example, GLTF, that you can put, for example, in Blender or in other softwares for 3D rendering or creating animations on external softwares. And this is very, very powerful, and I can show how to use it. So I can click install. And then I close. You see that a new icon was created here. If you don't see it, you go here, and actually it doesn't create anything inside. So this plugin is one of the few that do not create anything inside this list, but only gives you a button. Okay, so if you don't see the button, probably is hidden somewhere, and you have to look for it, basically. If you click this button, you get access to a new interface. And if you open up the 3D viewer, of QGIS, you get an error because there is a conflict between these two libraries. So if you forgive me, I just close for the moment QGIS and reopen it to show to you how this works if you don't mess up with the 3D visualizer of QGIS. So any ways you can pose questions, and I will try to answer live if you have any issues with this. But again, here we have our Mars mapping project opening up. Here it is. So let's try again without any 3D environment. So I just simply reopen the project, and if you go to 3D views, we do not have any 3D view. So this should be safe now to use this plugin. You see, now that I click it, I don't get any error message. And so how it works, you have this interface with this cursor, and here you can select your digital elevation model layer. In this case, I want to use the G0 Crater CTX DEM. Before doing that, as before, we have lots and lots of layers here. We want to basically use just those that we need, because all the time that you are creating a 3D environment, you are stressing a bit your CPU and GPU, and so it's a good thing that you use only what you need. And let's say that I want to create a beautiful 3D view of the crater, of the whole crater, okay? The nice thing about this plugin is that it's adapting itself to what you see on the canvas. So if you open it, you have the controls, 3D viewer controls. I don't know why this thing is not working today. Okay, so all the 3D axes, if you click on top of one of the axes, you can orientate it accordingly. And then you can select your digital elevation model layer from which the altitude is going to be taken and to be used for 3D generation. I click, I get this, and then with my mouse, I can rotate. And you see that, although very subtle, but I have the topography here. You see how snappier and faster it is in comparison with the one of QGIS. And you can zoom in and out. And if you want to orientate, for example, along the x-axis, you click on the x. If you want to orientate according to the y-axis, you click on y. If you want to be at the top on the vertical, you click on the z. So it's very nice. And you can do a lot of things. For example, you can adjust the scene to add the vertical exaggeration. So if you go to scene and scene settings, this window opens up. You can set a vertical exaggeration. For example, I don't know, I want it to be 5 times larger. So I have changed the elevation, and you see now it's exaggerated 5 times. And it's very snappy and quick. Maybe this is good for some sort of visualization. You want to be sure about some types of contacts or overlapping relationships. So this is a good tool to use. Scene settings, it's always opening on my other screen. You can put 1 again. And then the base extent, you can use your map canvas extent. So what you are observing here in your QGIS canvas, or you can select other extents, for example, a fixed extent or something that is related to a layer extent. For example, I want to use a different layer extent. I want to use the layer extent of my CTX mosaic. And that was called Jazz CTX, this one. I click OK, and then I have to click OK again, and hopefully, yes, it's adapting on the fly to the extent of my specific CTX layer. So if you see, it's using now the extent of this mosaic in particular. You see? Don't know if it's super clear, but okay. Another thing that you can do, since it's visualizing everything you have in your map canvas, you can toggle on and off different layers. For example, now I have toggled on my STX mosaic, but let's say I want to see something about Chrism. So if I enable Chrism and I go back to my 2D view, you see that it's on the fly projecting the Chrism data onto the topography. So it's very, very powerful, and we will use it later on to derive some information. If we want to use, for example, I don't know, Cassis, we can toggle Cassis, and you see the result. We have Cassis here. Now, we have a couple of things that we can say also about resolution. So let's say we toggle on the high-rise mosaic. So now we know that high-rise is super high resolution, but if you zoom in a lot, everything is very, very pixelated, okay? This is a sort of an optimization that this render engine needs to do to be snappy and easy to use and to visualize things on the fly. But you can adjust this. You can adjust this doing one thing. You can go to your DM layer, right-click, properties. And by the way, you can zoom to layer objects as you do in the normal interface of QGIS. You go to properties, and properties open this box. And you have few controls here. You have the resampling level. So it means that this is also resampling the topography. So although the topography can be a super high resolution, for visualization purposes, it's scaling it down. It's reducing the resolution of the topography, but you can increase it. Okay, let's say we increase it like that. And also it's asking you another thing, the image width in pixel. This is basically tied to the resolution of the texture. If I increase this, for example, 2 times, this is improving my texture. And for example, if I want to be a bit snappier, I can choose the JPEG compression and then click apply. It's going to recompute. And you see that we have improved the resolution quite dramatically. Okay. We can increase even more. So we go to properties. Again, it's on my other screen, and we can push it until to 4096 pixel resolution. We can click apply. I think you can also put inside your custom resolution.
And Riccardo is still with us, so the computer survived.
Yes, exactly. You see, we have improved the resolution even more. Now it starts to look really cool, really nice. And you see, this is on my not so new laptop, and it works pretty fine. Another thing that you can do, if you go to the scene settings, you can use your map canvas extent. So if you zoom in a lot, you play with the two, and you get always the most resolution in the 3D environment, which is again linked to your zoom level. If we zoom a lot inside, let's say we zoom in like this, and we want to check this particular area. Now it's going to take quite a lot of time to build the model, but hopefully it won't die. Let's see. Now, if we zoom in, this is becoming even much better. So this is a good way to go. You can also export your scene, or you can also save your scene. You can save your scene as an image, of course, or a GLTF, GLB, so a textured mesh to be put into Blender or whatever. You can also export your 3D scene in this particular QGIS to 3JS environment. It means that if you save a scene like that with save button, it's creating an auxiliary file into the folder where you choose to save it. And when you load the plugin again, you simply have to load the scene, and everything is becoming back as you had it before closing the software. Another thing that you can do, of course, you can play with the camera, perspective, orthographic. You can add the north arrow, for example. You can choose the color of the north arrow. Let's put it, I don't know, in yellow. It's down there. So if you want to, to create a beautiful visualization with the north arrow that is orienting according to your needs, this is a good way to go. If you drag the model with the right mouse button, with the left mouse button, you click and you can orientate at your need. You can also add header and footer labels. So delta and footer label. How nice. Apply. You can change the background color. You do it here in the scene settings. You can use sky or solid colors, for example, black. Now it's recomputing everything again because, of course, it's changing something in the scene. So it's very powerful and it's helping us also to do things. This is a visualizer. You cannot make calculations with this, but still is good. And you can export the scene to web. This is also another nice thing. Basically, you can save all your scene into a directory. You can browse and create a folder on your desktop or whatever. And it's creating basically an HTML file with some auxiliary files. And this can be then shown and played inside the browser. I can show you. And so you can have I create an HTML folder here and open it. And then we will save it here. Preserve the current viewpoint, enable viewer to run locally, so you can run locally on your computer. And you can also load animation and narrative, like an audio file or some keyframes to move automatically your object. You can export. And now I will show you what's happening. Okay, it's done. I can close. And this is what's being created. So you get basically index HTML, a bunch of auxiliary JSON files, PNG with a texture, other auxiliary files, etc. And if you double click this, you can open it on your browser. Like, for example, I will use Safari. And this is what's happening. So inside your browser, you have your model. This is a browser window inside my Safari. You can use Chrome, you can use Firefox, anything you need. You have some information here about the controls that you can use. You can make it rotate automatically with the R button. You can use mouse wheel to zoom in and out. You can toggle layer visibility. You can see wireframe, okay, of your model, which is nice. Lots of different visualization things. And if you double click on a point, you can orbit around a specific point. For example, I want to check this mound. I double click on the mound. I can orbit around this mound. And I can measure distance from a point to another point. So it's nice. This is just a brief, let's say, deviation to show you that when you have very, very beautiful data and high quality data, you can visualize them and help yourself. Also to derive a cross-cutting relationship or overlapping relationship. And this is what we are going to see in a couple of minutes. I think I then can pass again to Monica, if you want. And,
yes, of course.
If you have questions about this, you can write me on the Q&A and I would be happy to answer.
Thank you, Riccardo. I'm going to try to do something similar if possible. I'm not as good as Riccardo, but the idea is to use this tool to better visualize stratigraphic relations. Actually, it looks like a game, but it helps you to have a sort of Earth-like perspective to the location you're studying. So I would concentrate to start with this done, to look at the stratigraphic relations between these units, and then we'll move here. So I'm using this, I think that this can be okay. I had to prepare another okay, now we can also use the CTX DM for this image, because we don't need super high resolution to discriminate this part. What we see here is that I'm always fighting with this media. We see the crater rim here, our unit B, the valley. So what we can say about the crater rim is here, the unit A is, you see here, is onlapping against the crater rim, so it's younger. Okay, this is pretty obvious, that the crater rim, and after is cut by the incision of the river channel. Actually, some layers here are exposed. We can even, maybe later we can go and have a look at high-rise scale to how they look like. But what it's interesting is that from this very, very super simple image, and actually there is one last thing I forgot to mention, that the valley is infilled by Aeolian bed forms that you can see here. So we have from this again simple image, crater rim, unconformity, unit B, erosion, and then after the erosion and the, let's call it fluvial episodes, infilling of Aeolian bed forms, something that can be sketched maybe in this way. Maybe I can share this. This drawing is not probably super nice, but just to give an idea of the representation of the stratigraphic relations between the different units. Sorry. No, I didn't want to spoil it. Crater rim, unit B onlapping here, incision, and Aeolian bed forms. Let's go back to our, actually, I close it because sometimes doing this on the flight, it makes it crash. And keeping in mind this part of the unit, we can move to this part of the study area to try to understand the relations between the delta. We have unit B here, we have unit C here, unit 4 here, and the fan delta. Okay, needless to say, the relations between unit C, no, let me just shut up and go to visualize it. Actually, here we can be a little bit pretentious and use the high-rise DM. So what we do see, and I should have premised that there is no consensus in the literature among different stratigraphic interpretation. There are, you will see, if you will want to play a little bit with the publications, you will see that there are different interpretations. So be very critical also to what I am telling you, because maybe you can disagree with something. By the way, what I do see here is that this unit D stay on top of, we can stay on top of this unit C. Then there are some, we saw this Aeolian bed forms this morning, but Aeolian unit C is here, unit D stays on top. And actually this perspective is a little bit, I mean, it's good also to see other things. You see, unit D is reaching the one channel of the delta. It is embedding, it's moving like infilling one part, I mean the basal part of this channel, and then stopping here. So it looks like unit D, you see also here is moving and embedding, so post-dating the delta formation. Sometimes you might have some, let's see if this is a good place. You might have some impression, which is also, sorry if I want to say this, otherwise I will forget. One thing that will help you is that if you follow the layers of the fan, sometimes they will stop in correspondence of the unit D. It means that unit D is infilled part of this delta. So it postdates the delta. Sometimes you have another impression because some layers are, we can have a look here. Then, you know, I could play with this game forever. So some layers of the delta are really prominent, probably because, probably for sure, because they they correspond to a lithology which is more resistant to weathering and erosion to the surrounding ones. So when they are so prominent, sometimes you have the impression that if this material is infilling from the bottom, that it is older, because it looks like that this one is going on top of the unit D. But this is just related to the fact that these beds are really prominent. I hope it's clear, this part. And I think that also from here, you can see how this is embedding these small mesas, which might have been part of the delta before. And let's see if there is some more convincing situation. But actually, there is one more thing that we should address, because, okay, our delta, we saw that our C stays below unit D. We think that unit D is post-date delta formation, but what about unit the delta and unit C? If we look at this here, we see that unit D, that the delta is here is on top, in places on top of this unit C. This is very clear in this situation, but maybe this is also sorry.
By the way, Monica, can I interject? Since we are getting lots of questions about that.
Ah, okay. Sorry.
So these things here, these artifacts here, are something that are related to lack of DTM information. So when you choose your DM layer, like in this case, I'm marking here, and you have this type of situation, it means that your data are not covering, your topography data are not covering all the images that you are displaying. So when you have a lack of DTM, you will get this artifact. And basically everything where you don't have DTM is put at 0 altitude. It's like a flat plane. Actually, Monica, if you toggle on the layer just below the CTX DM, this is going to solve the problem. So you can also use multiple DM, just no, the other one, the one on the top. The M20, that one.
Yes.
It should be solving the problem. Yes, you see.
Yeah. It should
actually it's creating a sort of a box, and this is something that can also be be set in the scene. But I mean, these are artifacts, and these are related to the lack of data. So this is to answer a bunch of questions that we got. Sorry.
No, you're totally right. This was something that when I saw it, I thought I should tell something about, and then I was captured by the geology. Sorry, and you are totally right that if I switch to the CTX DM, of course I will lose, because you see.
No, you can also keep the two together.
I can keep them together.
Yes.
That's super cute. And
it's a bit of time to render, but yes. No. Okay. This time it doesn't work.
But okay.
It's also a visualization thing. It's not really a problem.
Yeah, it's not a big deal, because you can even switch from one to another to the other. I was using Irise DM because we are looking at very subtle differences, and actually
yes, and it's also better. So
yeah, but it's, for example, I was speaking, and then I brought myself, because I finally found like citing the song what I was looking for. Here I was mentioning before some prominent beds with more resistant beds. This is something that happens even on Earth. So this material here is infilling, but of course first it infills the space below, which is empty. And it might look that this unit is younger than this one, but it's just an effect of the topography, the topography of this bedded delta front. You see how this is almost drowned, this part. Also this this mesa, is almost drowned by these deposits. There was one thing that I wanted to show you. Now I'm going totally randomly, but let's see if I remember. It should be here. Yes, now I do not have the maximum resolution, and I think that if I go to,
you have to right click on the layer that you're visualizing, the jazz, that one. The third one, properties.
But it will
and then you have to adjust the texture width. The below, there you can increase it.
This will crash it. It's okay. Already no. Okay, because okay. Actually I will show you, because I was making this attempt several times during the past days, and once
I can check whether I can make it on my computer.
Because you can see, maybe I have, in any case I should have somewhere the image saved here. You can observe this geometry. I'm so stupid that I was drawing on top of it, but I can delete my drawings. And can you see the angle between these beds, these layers, and this one? Maybe. Okay, now I think it should be more clear. Can you see? This is a downlap. And the position is exactly this one. So it means that this part of the delta was prograding in this very moment. This part of the delta was moving towards the basin. I hope it was clear enough. Instead, I think it's worth to notice a bit that since with the 3D is much more clear that this valley is cutting the previous deposits. It means that this valley was formed following a sea level drop, because the delta plane is incised when the channels need to accommodate to the new water level. If the water level was here and then it drops, the channel is not in equilibrium here anymore and it should cut to go down. And this is what the channel did.
Monica, if you want, I think I have it.
Great. Bye. Yeah, super cool. Super cool. And actually you have also the top left, the horizontal layer at the top, which marks the most probably the progradation of the delta plane. The clinophores mark the progradation of the delta front, and the horizontal layer of the delta plane. So all the sedimentary body is moving towards the basin. I'm impressed.
I will make it a bit more high resolution. This is the maximum we can have.
Yeah, it's super okay. I think it's very clear. There is in particular that a very distinctive light tone bed, which is very helpful. Maybe I can annotate it, this one, which is very helpful. And this is instead these are the top labs. So it means that this was the initial situation with the what they are called bottom sets. So the beds will stay at the bottom, and then we have the progradation of the delta front, and then the delta front is somewhere here. Now we don't have it anymore, and then we have the on top of the clinophore. On top of this, we have this delta plane which progrades. This means that the delta, and if you want to check, there is a very nice paper by Gauge, I think 2018, but I might be wrong. Very nice, which tells you the story, the entire story of the delta, which is very dynamic, because we have this phase of progradation, then we have the at a certain water level, corresponding to a certain water level, then there is the incision related to, you know, the last valley. And this is a little bit striking with the fact that we don't have a lot of other sedimentary deposits. Actually, there was a discussion. Maybe Riccardo, is it okay if I take the screen? Take the screen back sounds.
Yes, sure.
Sorry, because okay, I closed this. let's go back to our, I'm sorry, in this project, to be able to make 3D, I had to delete some layers, but okay, we have an history with this unit B and unit C, which are the one rich in carbonates, but also rich in olivine. There was a question this morning. Many people were discussing about the origin of this deposit, which predate the delta. This should be always remembered. We saw the relations here, and we saw that here the unit D is cut by the fluvial channel. So they, at least in their last part of their evolution, they predate the delta. And there was a lot of discussion whether they were sedimentary or volcanic units. And there are good reasons for both the interpretation, and actually from our perspective, there is no way to make a definitive conclusion, but Perseverance actually was driving actually along this path and found that unit C is a igneous unit, so most probably pyroclastic material. So this, where are the other sedimentary deposits related to this delta formation? I leave you with this question because I was talking this morning about the necessity to try to correlate laterally different landforms belonging to the same phase of this evolution, but here things are not so easy because we have a valley, okay, which is mostly erosional. One might maybe discuss about the layer deposits here and here, whether they belong, or maybe we can. Okay, I'm super stupid. Let's go and have a look instead of just chatting. Okay, and here, okay, there are these, but we definitely need high rise. So here I am pushing probably above our the possibility of resolution that we do have. One possibility which it would be worth to investigate is whether these layer deposits here, which looks like they are below this big block here, they maybe might belong here. You can see something. These bodies here, maybe this might belong to a sedimentary phase which was covered by these possible pyroclastic deposits, and maybe this phase was not even constrained within the valley. It might have been definitely more extended. This would mean that these pyroclastic deposits, and we go back here, which predate the delta here, actually they may be coeval. So the last part, they might go, they predate the last part of the delta, but maybe they are interbedded with the delta itself, and they might be, they might post-date a first part of the delta. This is a possibility. The other possibility is that all the deposits of the lacustrine system, so the clays that we would expect, in the deepest part of the delta, have actually been all eroded away. So I have no, of course, no conclusion on this. I can just leave you with this doubt, and maybe you can mapping, while you are mapping, you can maybe develop your own interpretation of this. I might add something more if it's not too late. Do we have still some minutes?
Sure, Monica, go ahead. You are the
sure.
tutorial.
There's also a couple of questions later on, but yeah.
Okay, I will tell you.
Go ahead.
Just this, because this light tone part here, where carbonates have been found, if I'm not wrong, but also clays. They look really actually clays most of all. If we go in 3D, if my 3D is still okay, it's computing. And, you know, they seems to belong not to this fund, but actually to our fund. They stay on top of this deposit, which seems to belong to the unit B. You see, and they stay clearly on top of this unit. I don't know if I can convince you, but I think it's okay. It's pretty obvious from here. So what does it mean? Let's go back to 2D. What does it mean? It means that where is the fund from this side? Okay, this was not part of our exercise, but basically we do not have the sedimentary deposits related to this fund. So it might be that these deposits are actually below. This might support in some way the idea that actually this pyroclastic, if they are pyroclastic, but now we're just you know, brainstorming with the interpretation. If these are pyroclastic, they may have arrived when the deltaic activity was already active. So maybe part of the sedimentary deposits are below this double volcanic cover. Otherwise, the other interpretation is that all the lacustrine deposits have been swept away by erosion, which is also a possibility. I have a look at the questions. Embed, delete, it looks like they are sitting on top. This is something they were discussing a lot. To me, let's look at this one. Maybe they are more representative because that one is far. Let's go here. No, sorry. I don't think you can hear, but my computer is suffering a lot. This is a matter of discussion. I don't want to convince you. None of us is expert in this area. I must say that probably one good exercise would be, but to me, this is going through. This is moving to cover to embed this unit. This is a matter of discussion still, because if you go and look in the literature, you will find different interpretations. Also, another thing, you have these fractures here, which are very, very, very widespread in this unit here, for example, and they suggest some form of upwelling. If these all the, I think that D is younger than C. Let's go back here. D is definitely younger than C. And here, looking at the craters is tricky because I'm not an expert, but some of the smallest crater might not be crater. And then there is the problem of the retention age of this unit, which are different.
Yeah, probably there is a lot of exhumation.
So I don't know if this can be an argument to
Also, crater retention ages in such small areas are very biased.
Yes. This is also a good point. But I would say that, for example, if you look at here, that no, sorry. You cannot hear, but my computer is like, you see that this goes clearly to me on top of this unit. So D stays on top of C. Then you can think about how, if you agree that this D unit embays the delta or not. Still, the problem of the missing sedimentary deposits is there. And I think it is also a form of disappointment for the Perseverance team, maybe. But still, this is a nice geological problem because...
we can ask Gwenel afterwards.
Okay, yes. So, okay. Okay. Well, it is craters. Okay, we were discussing about how risky it is to trust too much craters in such small areas with also different lithological content. So I would leave the power to the trafficability part, if you agree, unless there are questions, of course.
Also known as Spiegoni.
Yes, now there's a clarification. Sorry, I was miswriting. If D is younger, why it has less craters?
Yes, I was trying to reply very poorly. The point is that, okay, one point is that in such small area, craters maybe are not so reliable. A second point is the retention age of different lithology. The third point is that maybe in Unit C and in Unit B, we were speaking about quasi-circular depressions. I'm not so convinced that many of them are craters. They do not actually look all craters. Some of them, yes, but some of them probably are not really craters. You missed which one in B is B, so give me just 1 second. I share the screen again, and I will show you. It's the easiest way. Okay. The Unit B is this one, which goes up to here. It, in some way, it's over the rim here, and it is okay. Here, basically, you find nothing because it's covered by the Aeolian material. Is it okay? Okay. I think you can go with the trafficability if you want.
Okay. So Angelo, what do we do? Do you share your screen?
I can share and then we can eventually switch the share if needed.
Yes.
Correct? Let me just do it. 1 second. So, okay, here we go. So we are back where we were after 2D and 3D. So now, if we just concentrate for a moment, removing the CTX on the detail of the landing site. And we were discussing before that actually the material here, it's covering various of the units. We discussed CD, the delta itself mainly, for what concerned the traverse of perseverance. But of course, you may want to design your own, and you are very welcome to do it for your mapping exercise. Basically, what we can start looking at, and Riccardo, please feel free to jump in at any time, is which is the setting in terms of morphometry, morphology, topography, and derived parameters of this area, which is across the delta and the crater floor with its different units. Now, Riccardo was introducing already that we have a multi-scale coverage of data here. We do have, for example, a larger CTX model, which of course doesn't have that much resolution, but the main features are visible. Of course, doing an inch shade will be even more visible. You know very well how to do one. In case we have time, we can do it. And we have, of course, this subset at CTX scale. Now, the morphometry area, if we just turn off for the moment the map, the morphometry area and the traverse also has different layers. I would like to go through them in increasing order of resolution and decreasing order of coverage, which means that we will start with the CTX based one. And here, Riccardo was computing some morphometric parameters that actually are able to calculate with TPI different local morphologies. That's very handy, of course, when you map things, for example, because you can really see where the scarp are. But in this case, it can discriminate between what is flat, which is kind of greenish, what is bluish, which is kind of concave.
Precision. Yeah.
Yeah, concave, and what is convex, which is, for example, the positive things. And obviously, as it makes sense, these mesas and butters here are actually quite convex at the surface.
For the people asking how we did it, it's simply enough to type TPI in the processing toolbox, and there's an option in Saga GIS, which is this one, TPI-based landform classification. You run that, and you end up with this map. And the color coding basically is because this is creating a raster which has 9 different colors, a color palette of 9 values, and you simply need to adjust the 9 values color palette, matching each one a different color, which is something we have seen plenty of in the past days.
And for
example, yeah.
Go ahead. In this case, Riccardo was choosing a rainbow like palette with discrete classes.
And then you, of course, have to type the label. I did it by hand, but These are more or less hard-coded, and you will see in our GitHub page all the references for this type of elaboration, which is a bit time-consuming. So don't run it if you have not a powerful machine. This particular one that Angelo is showing, it took for my workstation with 16 cores and 64 gigabytes of RAM almost 4 days. So it takes a while.
On top of it, of course, you can do with this particular, but the nice thing is that this classification shows very nicely the inlet and outer channels. And of course, many of the features that are also available in terms of also grabber-like features or channel-like features that are outside the crater. And probably
this is, sorry, so can I add one thing? This is not a substitute of a geomorphological map. This is just a help to detect features that maybe you don't see with naked eye because the image is very rich of texture in the case of Mars. But also this is something that is commonly used on Earth also. But when you have such a variegated landscape, it's also good that you are able to highlight different topographic expressions. These are not morphologies, these are topographic expressions. So a geomorphological map is something different. Sorry, Angelo.
Yeah, no, that was very, very good point, Riccardo. On top of it, of course, I mean, here we didn't include any shade, but you can very much do it. You just have to look for the shade. And you can create either with this or with this one. Should be the same. And in this case, I selected this DEM. This I think we should do it. It's not a problem because it's not so much. We can save it as temporary file. And this tells you two things. First of all, that of course, many features that you can see both on the topographic product are visible here, obviously, because the data source is the same, it's topography. The second thing is that you can also see the artifacts that are there. If you're not looking at the hill shade, sometimes you may just say, oh, let me map here and just map on the topography, and then you add the layer, and you see that there is something here. Of course, this is an artifact due to the different blocks of different data products or stereo pairs that have been merged together in the process. That's something to pay attention, of course, regardless the interpretation of the morphologies, but that's an obvious one, because typically this blocky appearance or very sharp, you can also see here. But overall, it's a very nice DEM, actually, at this scale. The Arise DEM, same story. It's also a very nice DEM, and it's incredibly well co-registered with CTX. You can see it mostly with the images. And if you like, you know, you can also run in the shade of that. And where is the Arise DEM? You know what? Since I'm lazy, just select it and then around the shade. Yeah. The resolution, I think. Should we try to have it as a temporary, Riccardo? It's not too bad.
Yes, it's not too bad.
I mean, I just don't want to crash the Zoom webinar, you know, that's my only concern. I can crash QGIS, it's fine. So basically, the point is that you can and you should use all of this data, and they are very complementary. So apart from the overlaying and multi-layer, in general, different topographic or topographically derived products.
Yes, it's the one we are seeing now. Yeah.
Exactly. Yeah, but since it's very well registered. Wait. 1 second. Yeah. No, the shade should show up. Yeah, so you see, that was the typical case where you have no refresh. Anyway, now you can see that actually that's pretty good. It's impressively good, in fact, is the TMs. The seams are not there, and you can really use this product not only for trafficability, but just for mapping, because it doesn't have the albedo issues that you may have in the mosaic, and it shows very well at a scale very comparable with Arise, probably few cells of it, the different units. For example, C and D are showing up very nicely in the shade, as well as, of course, the erosional features and the possible changes on the delta. On top of it,
it's also so impressive. You see also the dunes.
Not only you see the individual dunes, but look at here. For example, look at this guy. You see, there is a kind of a roundish appearance of it. Of course, this may also be, previously present craters that have been buried and that are filled. So it can be not really like a ghost crater, it can be something else also. Then you start seeing features what already on the CTX, like this kind of lobate bits of it. So the outskirts of the mesas. So in principle, this is already a very good product that can qualitatively show you where smooth is smooth. And while at CTX scale, if you call something smooth, you can call it at 20-meter resolution. Here, of course, you call it at metric resolution or just plurimetric, which means that even something qualitative like that can be very much guiding your initial evaluation of where to pass. For example, that's quite obvious. Riccardo already brought it up. They didn't really go into this rough area because it's full of aeolian material, it's rougher, there is scarps, so you really want to go around it. Particularly if you are at the beginning of the mission. You remember the talk of Fred, if you are later on in the mission, you may take more risks. And also the talk of Riccardo on the same day. At the beginning, you don't want, and since, perseverance had to pick up still the samples and deposit them, that was probably a very sensible idea. Nevertheless, we have also other data which are not only usable in a qualitative fashion, and in this case, I think we just start with the slope of our ice, which is cooking. Yeah. Now, we may want also to do some overlay or simply just do some transparency. Because the color coding chosen by Riccardo is actually quite good. And in fact, while it may be a bit confusing to put transparency of this in an image, transparency of the slope of the same data source on the topography in shade is very effective. Here you can see how, and it makes sense, qualitative and quantitative approaches are consistent. In the sense that, of course, what is green is flat, is smooth, which means the digital number variation is not there and everything is kind of gray. When you have a rougher terrain, you can see that also the digital number changes, and obviously you can see the morphology changing in the shade. This kind of detail would be very difficult to appreciate at the scale of the DTM itself. Even
by the way,
doing,
Angelo,
for example,
these are actually the threshold of tolerance of perseverance. So 10 degrees is green and 15 degrees is yellow. Everything more than 15 is, as always shown in the school, is red, so not trafficable.
And by the way, we can also start seeing more or less an envelope, how much was the topography delta of the path, For example, we can see how much perseverance had to do in terms of climbing. Sorry, do it again. You see, it landed at about minus 2,470, and then it went down of 10 meters. So you see, everything is around some 20 meters of topography. Along how many kilometers? A couple of kilometers, right? So this approach, of course, as I said, we are doing a post-mortem. We are doing an evaluation of what has been done. But you can do it before, for example, for your planning, which is your budget of topography, and also, like Fred was mentioning, how much you want to, for example, sample a stratigraphy because you want to go up the series or down the series. So that's actually very convenient. And we can do it again, a bit low resolution, but it doesn't matter. It gives the idea. You see how we were climbing? Now let's think about, we want to actually go through C. Okay, we keep it like that. Shade is better. Yeah. Now imagine that we wanted to do something like that instead. Directly, okay? First of all, topographically, it's not so much different, but of course, it's a rougher terrain. But then, obviously, this part, you see how it's climbing up? That's obviously the delta front that you cannot really approach like that. And that's where we can look again at the slope and see where did it.
Maybe Angelo, I can show the 3D view of this. I have it.
Ah, yes, please, Riccardo, I stop and you can start.
So here it is what Angelo was showing you. This was, I think, the landing, and then it went down here and then came up. This is actually great on top of the images, but you can clearly see that they try to move away from this ridge. But at a certain point in the path, it was more convenient to go down this small slope in between these two 15-degree sloping, but inside they found a sort of a path, which was green, so less than 10 degrees, which was doable, and they were avoiding this rough terrain here with all these cracks and polygons, and so they decided this was safer. And then more or less they were staying around this edge here. While they were climbing up, they stayed in between the edges of this crater, and they did this path just because of what Angelo said. Although this part here topographically looks fine, of course you cannot climb up the delta here. You see how different it is. Instead, they approached it differently. They went up here, they took the chance to go up here. Probably this is not super well registered. They were able also to image what Monica showed you before, but of course not go there and see super in a super close-up view. But there's another thing that you have to pay attention to, which is probably what Angelo was about to say, is that here you have to cross a field of dunes. These are all dunes, and you don't want to cross them. And you don't see them quite well on the DTM and the slope map, because probably they're not sloping so much. But what if we toggle on another layer, for example, the TPI, so the topographic profile expression. This is showing us a totally different story. Give me a second, and you see how different it is. Before, the slope looked safe, okay? It looked safe. But if you want to go through here, actually the terrain is not so safe because it's full of small depressions and small culminations. You see, all the depressions are marked in blue and all the culminations are in red. These are taken using this algorithm that, if you want to have the details, it's the talk of me and Angelo yesterday about trafficability. Basically, it's calculating the average of the terrain around the pixel and then seeing if the nearby pixel is above or below the average. And you can construct this map, and you immediately see that the safest terrain was to go around this pit here. This basically, I think it's an unit. What was the name? Unit C. So you can avoid to traverse all these dunes. You can take the chance to go above here because it's not so pronounced, so steep, and so convex. And then you can try to go and reach the sampling site. And by the way, while they were crossing here with the TPI, it's also possible to see the dune crests. And you see here, if I zoom in, that they stayed between a dune and the other, just following the long axis of the dunes, passing in between them to reach up a safe place, and then trying to climb up. And they always climb up in between large topographic expressions where you have the less risk of having troubles. So this is a very, let's say, qualitative analysis of this. I don't know if, Angelo, you want to say something more, but this is very nice because you can really analyze what the team did in terms of planning. And you have to imagine that also the Perseverance rover has a sort of autonomous guide, which is helping him to detect and avoid small obstacles along the path. But from the satellite perspective, which is what we have, the rationale of what they did is, I as its point. So it's really what we would have done. Also here you see that they climbed up in between these two major convexities, reaching up this base of this wall, which they probably sampled, and then they tried to climb down here. So they take probably a risk here, but it was a calculated risk, or maybe it's not so well registered, the path, because we had to do it actually by hand, right, Angelo?
No, actually this should be registered because it should be actually
okay.
well placed. We were checking it.
Okay, so you see how it appears. So when you load this type of topographic variables, you immediately see where you cannot go. Whereas if you don't use lots of them, you simply, for example, revert to the topography and to the slope. Here I can use this. Here the slope looks safe. Everything is green. If I limit the transparency, you see, everything looks safe. So you may say, why cannot I go here? Why can't I traverse here, which is safer? That's because we are in this situation. So it's always good to play between two different layers of information to get the most out of it in terms of safety.
Yeah, exactly. And I think one of the points to close here is that this is a very, very lucky place because we have one of the best really base map setup ever for a landing site. Fred was mentioning it. So obviously, when you're doing it in your area, this exercise, it will be more challenging, but still the tools are the same. And within the limits of your data set, the approach of using an integrated set of topographic raw and derived product can be very helpful for you to plan your own, so to say, desired exploration or in general, possible traverse.
And nonetheless, they were so lucky that they were able to reach up this area, which is what Monica was showing before, where you have these downlapping layers and then the flat surface at the top. And they were able to reach it up with the rover. And at least to look at it with the, how you call it, the panoramic cameras from here. And now the game, what could be the game? The game could be, okay, we arrived until a certain point. We have a full delta to explore, where we can go and how. So we can simply switch off some of these layers, start looking back at images, and start wondering, what is the best place where we could go next and how? And if we toggle on again the slope map, we immediately see that if we want to climb the delta, probably this is not the best place, but we can go around this bank. We can try to traverse this dune field and we can detect it by using TPI. And in fact, probably we cannot go through it, but it's better to stay close to the edge here and to try and climb up somewhere here. But here it's not possible anymore. So maybe it's a better idea to go around here. And why we want to go up here? And for example, because we have these beautiful exposures of layers. So this could be other good sampling sites or sites for in situ analysis. But can we reach them? Again, yes, maybe, or maybe not. With the slope, we can go through here and maybe reach up this point. With the TPI, maybe we have to choose a different path. And this is a good exercise that all of us can do by having this type of data that we provided you and try to design your own traverse and see whether it's feasible or not. So where can we go from here? Which is our next scientific objective, yeah?
We have some questions for the last minutes, which is the main difference in computing the slope and TPI, apart from the computing effort?
The main difference is that the slope is the first derivative of the DTM. If you imagine a DTM like a function, and you calculate the first derivative, this is the slope. Second derivative, sorry, no, this is not true. This is wrong. The second derivative is the curvature. The TPI is not the slope because you have no information about the angle of slope. you have information of what is above or below a surface. If you wait a second, I will try to go back to the presentation of the day before yesterday, and you will see immediately the meaning. Or if you have it handy, Angelo, there was a slide explaining exactly that. Let me see. Here. Yeah, this one. In a second, I will. So TPI basically is this. What is it? This.
It's linked from the repo, Riccardo.
This is the TPI.
Oh yes.
Okay.
Indeed.
So it means that if you have a topography, and you have always to set TPI is a scale dependent topographic variable. It means that you have to choose a window of analysis, a window kernel size. And then when you analyze your topography, if you have chosen an appropriate for your scale of analysis window of search window in the matrix of pixels that composes your image, it's able to detect what's below and what's above the average of all the pixels within your search window. Here, for this purpose, I chose a different approach. I didn't choose just one search window. You can choose multiple search windows. I chose 3 search windows, and then you can put together the 3. So, because, for example, a search window can make you overlook small features, but can detect large features. A very small search window like this one would probably show that everything is flat here. This search window will probably show that this is a culmination and this is a depression. A very large search window shows everything here as a depression and all that's outside as a culmination, as a convexity. If you choose, for example, 3 different scales, which needs to be really tied to your scale of analysis, and this is basically a matter of what you want to do, you can choose 3 different TPI, and then you can create your summary map product where you have all the 3 scales combined together. How to do that? You do that by using the multi-scale TPI. It's called topographic position index. If you use the one from Sagagis, you have, for example, 2, minimum radius and maximum radius. There are other modules that I don't have here, which can calculate a multi-scale TPI. For example, you have some in ArcGIS, you have some others in the standalone Saga application. This is for example, the defaults, minimum and maximum radius of analysis. If you tweak them, for example, you choose 10 meters, you get the smallest window, so the one in here, which is 10 meters, and the larger one, which is 100 meters. So you get all the features in between the 2. There are quite a few publications about this, and I encourage you to read them. We have put the references in our GitHub page, because this is very powerful instrument. But
I'll
since
put it
it's
on the chat, 1 second.
Since it is so scale dependent, you really have to be careful on how you use it, and that depends on the scale of the analysis you want to do. Okay, so this TPI topographic analysis does not provide a unique answer. It provides a unique answer to your scale of analysis, but if you change the scale of analysis, the answer may change. I hope I answered. I know it's a very complex matter, but we found it really, really striking in this particular setting.
Well, actually, that will be a wrap. I don't know if Monica wants to say any concluding words, because I think that then we can.
No, I think it's okay. It was really fantastic. Bravi.